Welcome. As Phil graciously announced me, yes, I am founder and CEO of a local company here called ClearBlade. We are an enterprise Internet of Things software company. So you heard from the strategists, these guys are probably a little smarter than I am. We're the nerds. So we're software guys that are focused on enterprise Internet of Things. So my talk today is about what is enterprise Internet of Things. Before we start, I'll admit I'm a pretty interactive person, so I can go off topic. So I'm going to count on you to keep me on topic and keep me interesting. Otherwise, I'll just bore you and then we'll get to drinks. Deal? All right. Oh, a clicker. Thank you. Which one? Of course, I'm not the one that writes the software, so I got to figure the clicker out. Where's up on this thing? Oh, big green button. Pretty good. All right. Like I said, good start. So enterprise IoT. It's all about IT and OT convergence. Big green button. So what is IoT? Let's just start real simple, real simple. And I know this crowd is way more advanced than most people I talk to about IoT. But simply, what is IoT? Someone, definition of IoT. Someone's got a definition of IoT in this room. Otherwise, we would not be here. Come on, give me a simple one. Okay, Internet of Things. Good. But what things? Connecting the unconnected. That's a great definition. Connecting things to the internet, things that typically weren't previously connected to the internet. Internet of Things. I belong to a number of groups, and mostly, sometimes what we talk about is these things. And this is Internet of Things, right? We're connecting things to the internet. Fitbit, Nest, Amazon Echo, Google Home, August Lock. These are things that mostly folks that I hang out with sometimes talk about. Even the Budweiser hockey lamp. I'm a huge hockey fan. There's a company that's created a hockey lamp that will light up anytime your team scores a goal. And they talked about it in Berlin. It was the most wonderful thing, and they had to slow down their software so the light wouldn't go off before you saw it on the television. Hey, these are problems. These are difficult problems. So I'm saying these, and I'm not belittling consumer Internet of Things. This is hard stuff too. These are point solutions that do certain things. Now they start getting more complex when you start combining the things with the people, with the locations that they're in. It's about context. So I'm going to try to differentiate between this type of Internet of Things and what I call enterprise Internet of Things, or also industrial Internet of Things. And I struggle with this. This is not something that I just came up with yesterday. I have a team of smart people. We debate it all the time. So the simple description of Internet of Things that I have is connecting people and places and things to the internet. So I call this my Sesame Street version of IoT. So it's taking things that typically were not connected, like the bear that I had when I was in grade school, and now connecting it to the internet so mom and dad can watch me and make sure that I'm safe. But how do we differentiate those things from enterprise IoT? Anyone brave enough to take this one? Scale's a good one. That's an excellent one. Complexity, excellent. Yes, standardization. ROI, business, money.
It's also on the other side, it's not always end user, it's
True, very true. It's all these things and more. In fact, to define this is really difficult. So I'm going to attempt to do my best here. Connecting, at least the definition that I have, is connecting complex systems to the internet. So when we talk about complex systems, we're talking about things like operational technologies. Now, I'll admit, I'm not an OT expert. I come from the IT side of the house, but These things are really complex. In fact, different segments of OT are extremely complex. So you've got things like factories, right? You've got SCADA systems, you've got plant floor systems, things that have typically been M2M systems that are connected but not connected to the internet. These are closed loop systems that have existed for decades. In fact, I was on stage with a really smart gentleman last year. We debated where are we in IoT? Are we in the first inning or are we in the ninth inning, to use a baseball analogy? He said we're in the ninth inning because we've been doing this for decades. And he's not wrong. He's completely correct. Depending on your perspective, I think we're in the first inning because we've been doing this for decades, but we have not been connecting it out to the internet. I think we're both right. I think it's hard to debate that. We've been doing this for years. I heard Stephanie say it up on stage here. This is not new. M2M is not new. But IoT, or the definition of connecting M2M systems to the internet, is new. And it introduces a whole another set of complexities. Trains. Train systems, control systems. Is this train going to go off the track at this speed, at this temperature? Those are systems that are in place, but these are now being modernized with IoT. Warehousing. Where are my products? Are they going out the door at the right frequency? Are they in the right place at the right time? RFID technology. These have been in place for years, but now we're connecting them to broader and more complex systems. Smart buildings, smart cities. So now let's take that chiller example and connect it to my lighting system, to my safety system, to my elevators, to my security system. These are multiple systems that have to interoperate. So this is enterprise Internet of Things, and it's extremely complex, but people are building these things now. They're doing them. You heard it up with Bob and Kurt. Great examples of getting started with enterprise IoT. Now we're talking about connecting these to the IT side of the world. Typically, these constituencies, these two groups of people don't interoperate on a daily basis. And if they do, they don't speak the same languages. Different protocols, different acronyms, different clothing, right? I got a hard hat or I got a tie. It really depends on where you're coming from. So we see the complexity of the business model here, which is probably even more complex than the technology. You heard it up here before. So connecting ERP systems and HR systems and CRM systems and MES systems and financial systems, this is hard enough by itself. Now we're going to mix this stuff up and connect them all together. Easy, right? We'll get this done in the next 2-3 years. Done. Now we'll go on to some other acronym. AI, we'll go on to having Watson solve all our problems. So this is also going to connect to the internet. So these are now closed loop systems that are now being opened up to the internet. So we now have security concerns. We now have multiple constituencies that will be looking at this data. We now have latency issues, right? If I've got a piece of machinery that's running a rule that says if Eric's hand is detected underneath this saw, stop. I don't want to count on Amazon having that message get back in time. I want that on the machine on the edge. And thank goodness we're talking about edge computing now, because edge computing is really, it's new, but it's not new. It's the same pendulum swing we've all dealt with, for those of you that are computer nerds in the room. Centralized versus decentralized processing. It's always been there. I'm dating myself now, but back in the day, the computer was the mainframe. Then we went to PCs, and it was all about the PCs. Mainframe's done. There's a lot of mainframes that still run a lot of stuff in this world. So this pendulum swing is going to constantly be there. Use the machine for what it's best at, and it will balance out. So connecting complex systems. This is a definition of enterprise IoT that we use. Take a sip of water. So a good definition is enterprise, IoT is the convergence of complex IT and OT systems. So let's go further into some examples that some of you heard today. I've got a few more. Smart building. So if you've got an escalator in a high-rise in Manhattan and a security guard, you want to make sure that you have these systems tied together. So what can you do? Let's look at business outcomes. What can you do if you've got all your machines connected up in this smart building in a way that can notify maintenance when there's a problem or before there's a problem? Well, one of the statistics that we've seen is I can reduce my maintenance cost and staff by 90%. That's interesting, right? At the same time, I can increase my safety for that building. I can increase the security for my building by knowing who's supposed to be in that building when, by facial recognition from cameras on the way up the escalator, by knowing that Aaron has a meeting and you're allowed to be there at 10 a.m., not at 1 a.m. You're there at 10 a.m. Manufacturing. So manufacturing systems, knowing when machinery is failing or before it fails. Downtime is extremely expensive. And companies it's very costly when something goes down for unplanned maintenance. We've learned this over the last few years in the customers that we deal with. So how about if I improve my uptime or reduce my downtime by 75%? So say I'm down 2% of the year and I'm now down way less than that. I'm not going to do math on stage. It's pretty simple. And then transportation. So what about now having visibility into all of my assets on a train system? All of my locomotives, all of my cars, all of my railroad crossings, knowing that they're functional. What if I can increase my visibility into all my assets by 100%? I can see them real time all the time. And we heard it before. Real time is extremely important, but it's hard to do. So these are business reasons, and we can go on and on and on with this. And it's almost more, in fact, I think it is more important to understand what your business outcomes should be before you even talk about the technology part of it. And that's me as a technology nerd telling you this, because when I look at our customers and where they struggle, I'll be honest with you, it's not with the technology side, it's with the business side. How am I building this new market? I don't have the personnel now to run a software system. We heard it before. These guys have been doing it for years. So I'm going to tell a few stories, hopefully briefly. Related is a big real estate company based in New York City, and they have a project called Hudson Yards. Hudson Yards, have anyone heard about Hudson Yards? So I did not until we got engaged with them last year. They are a $20 billion private real estate company or project in the west side of Manhattan. So they're building 16 high-rises above the Hudson Yards railway system. So they figured out a way to use that railway system as mooring for these large buildings. So basically a city within a city. So building up instead of out, transforming a whole section of Manhattan. And they went in with a mission beyond making money, probably secondary to making money, of building the smartest buildings in the world, most advanced buildings in the world. So not only are they transforming this part of Manhattan, but they're also transforming the way we think about smart buildings. And when you build a smart building, there's hundreds of different types of machinery in that building. You've got HVAC chillers, right? You've got lighting systems. You've got micro power grid in this installation. They've got their own power grid that they actually switch between natural gas and Con Edison grid based on the price of energy. So if you've got a smart building, what type of IoT technology do you need for that smart building or smart community? Lots of vendors will sell you something that will drive their smart escalator or their smart elevator or their smart lighting system or their smart HVAC or their smart whatever, right? But if I'm the CTO, CIO of Hudson Yards, I can't have 126 different software solutions for my smart community. I need one converged, unified platform of IoT. So this is tricky. And I've seen customers like this spend a number of years trying to build this from the ground up. So there are technology challenges as well. And when you look at the myriad of IoT companies out there, They look like there are 500 of us. There are far less when you start talking about enterprise IoT, and there are far less when you start talking about horizontal implementations of technology. Now, I agree what was said before. I think if you're going to be really good in this space, you should specialize in a vertical market. But there also have to be some horizontal software underpinnings for you to be able to grow on. Underpinnings that are cloud agnostic, that are device agnostic, because at the end of the day, if you're a big enterprise company, you need to own your technology. So be very careful about weaving API calls in to a single vendor. I'm not saying it's bad, just know what you're doing. Because once you do that, you're married. And there's some things you want to keep unmarried because you want to have the ability to move that software. All right, I got on a tangent slightly. Back up. Stanley Black & Decker, another customer of ours. So digital transformation you heard earlier, they organized around digital transformation. Several years ago from the CEO down said, Stanley is going to be a software company. Otherwise, we will not be a company in 20 years. So they've made it their mission. They've created a whole new group and brought in outside people. They've got a big building in Atlanta that is focused solely on digital transformation across the enterprise. And they did some work on saying, hey, should we build all this from the ground up, or should we buy these different components? So they bought, thank goodness, and they focused on a few different business areas. So the first was DeWalt. So I learned a lot about construction over the last 2 years that I knew nothing about. Aaron and I have hard hats and boots that are unscuffed, so we get laughed at when we're on the job site. They said they're the software nerds. They can't lift a hammer. You see the GE commercial. We love that one. But what they're doing with construction is fascinating. They are connecting people, places, and things around the construction of large buildings to make construction more efficient. It's an extremely inefficient process today. To make it safer for the people doing the work. So now I don't have Joe, the jackhammer guy, running a jackhammer more than 40 minutes because there's a condition where they lose feeling in their fingertips permanently if they don't take a break. So they can audit trail all that. So I can stick sensors in concrete to know that it's cured and notifies the next group of folks to come in instead of sending Jane with a stick to go poke it. I'm not sure if that's what they do, but it's more automated than that. On and on and on, to cordon off areas where they're laying down electricity, and if you're not badged correctly, you're not allowed in there. It'll basically warn and flash to say you're not supposed to be in this zone because you could get hurt. So it's fascinating what they're doing, and they're rolling out this solution as a business to Whiting and Turner and Donahue and all the other construction companies. So it's a whole different business model. So where they're figuring out some of the bumps in the road are how do we go sell this to our customers now. So connected job site was the first. The next that they tackled was smart manufacturing. So they have customers that maintain jet engines and vehicle fleets. So the analogy I use, what I learned is if you lose a bolt or a wrench during jet engine maintenance, that's a bad thing when you do a jet engine test, or could be a really bad thing. It's like counting the gauze and clamps when you open up a patient, right? You need to know where everything is before you do that test. Otherwise, it's an $8 million mistake. Stanley's got solutions now that they sell to their customers for tracking all of this equipment around the maintenance of jet engines and vehicle fleets. All right, one more example. One more sip of water. BNSF Rail up in Fort Worth. I got to tell this part of the story, Aaron. So Aaron and I go up there naively about a year and a half ago. We're all loaded for bear. We're going to sell them positive train control infrastructure. And these guys, heavy network engineers. So we're up Fort Worth, around a boardroom, and they just let us go on about with our pitch and demo and graphics and trains on videos. And we say, look, and they're nodding their head. And Aaron and I think we're doing great. We think we're awesome up there. And all of a sudden they said, guys, you know what? What you told us was really interesting. Then they opened the curtains to the room we were actually in, and they said, here's our command center. We built all this already. This is done. but thank you, we'll call you. So Aaron and I are driving back a little dejected, and he's like, what do you think's going to happen? I said, we're not going to hear from them again. And lo and behold, about a month later, they said, we want you guys to drive back up to Fort Worth. And Aaron's a planner, I'm not, so we make a good pair. He's like, what are we going to do? What do I have to have ready? I said, we're just going to go and we're going to listen to what they have to say. So we go up and they say, look, you know why you guys are back? We said, we have no clue. I said, well, you didn't really try to sell us anything. You talked about your technology, and we looked at a potential solution, and we think that your software may be a fit. So long story short is what they did is they said, look, we've spent tens of millions on this positive train control infrastructure over our radio network. And now we think we can use your edge compute technology and your on-prem platform, because we don't do anything in the cloud at BNSF, to now monitor and control all of our 20,000 railroad crossings over our network and make them more efficient, make them more two-way communication. So luckily, we've been engaged with them for the last year and a half, and we've proven out everything that they need to see, and they'll be rolling out software on 20,000 railroad crossings over a radio network. So, we talk about 3G, 4G cell. Being network agnostic is just as important, because you never know what the network's going to be. They're changing from 3G, I think in this case, over to their radio network. That could end up being direct connect, CAN bus, Modbus, it could be anything. So being protocol and network agnostic is also important. So those are 3 real-world examples. And again, we're not train specialists. We're not building specialists. We're not manufacturing or construction specialists. We're middleware nerds. Middleware is not cool anymore. I guess you have to call it a platform. That just confuses me. It's middleware. Middleware that is secure from the ground up. I think it was Stephanie's group that talked about security, and I could not have agreed more with Nadine, was it? When you talk about security, it needs to be at every layer. It must be at every layer, and it has to be thought of from the day that you start building that platform or that middleware. And that's not the only solution. It's got to coexist with hardware security from NXP. It's got to coexist with your firewall security and all of the things that you already have in place. All of these solutions are brownfield solutions. These aren't brand new machines. So you have to dovetail with what's already there. Right, I digress again. So IoT architecture. So getting back to technology for a bit, here's what we've learned. We see a pattern, and when we put this slide up, pretty much we get nodding heads. This pattern is pretty consistent across all of these verticals. So at the top, enterprise applications. So this is your IT side of the house. These are the folks that wear the Sansa slacks and knit ties. That's disparaging. I wore those things too, so I can say that. These are your enterprise applications that have existed for decades. This is Database Natural, this is COBOL, this is JD Edwards, this is IBM, Oracle, Microsoft, you go on and on. So those things run your business. These are your systems of record. At the bottom, you have your things. These are your OT folks. These are your things. These are your system of things. And this is these two worlds colliding now. So we're bringing systems of things to communicate with systems of record. And to do that, you need some interesting middlemen. Real time, we talked about it earlier. Real time is extremely important. Real time's hard, especially when you have systems that are 20, 30 plus years outdated, right? But they still run. And guess what I learned a long time ago is old systems typically don't die. They slowly, slowly, slowly fade away. I don't think we expected that code written in 1967 would still be in production. It is, folks. And I want to tell you where I started my career, but it was air traffic control. And I think things are better now, but late 80s, we were rebuilding that air traffic control system. So as a 22-year-old, I learned how old systems really were. So in the middle, in order to connect these things, there's your platform or middleware, and that, from the top down, is really where it needs to be cloud agnostic and on-prem or cloud. So you can containerize it and move it where you need it, because guess what? Your solution may change over the years. You may start on-prem and move to the cloud. You may start cloud and move on-prem. You may start in one cloud and decide you want another. You may want to load balance between two different clouds. You may build your own company cloud. So the ability to move this software we think is critical. And then edge. Thank goodness we're talking about edge compute, because the more we talked about edge a few years ago, the more people thought we were nuts, and we started to question ourselves a little bit. But edge compute is real, and it's a must, because that latency issue is real. And there are two different paths, too. There is stuff that needs to be real-time on the machine, next to the machine, and there's stuff that you want to analyze later. So you may want to throw that in the cloud while you run on the machine. Run your rules on the machine, analyze in the cloud, and then update your rules on the edge. So in order to do this, you've got to be able to replicate systems between on-prem and cloud and edge. The same system, not a part of your system, the entire system. Visualizations, rules, execution, streaming data, filtering of data, security, and it should be bidirectional. So if I make a change on that edge, it propagates up to my platform. If I make a change on that platform, it propagates down to that edge. So here's my little plug for what we do. We focus on those two pieces of middleware. All we do is sell middleware licenses on an annual basis that sit wherever you want to put it. Again, we're not experts in train or buildings, but we work with folks that were just like was up here before. In fact, I want to work with those folks that were up here before, because in some ways that's the harder part of the equation. What's the business model and how do you put these things together? And we work with hardware companies that know how to build the best of breed hardware and then put our software on that hardware. So we talked a little bit about this in the last session, which is where do you start? So we came up with this maturity model, which is, look, you don't want to go and attack this all at once. You want to start with that you start getting data, and then from that, move up the stack. Start looking at filtering that data, start looking at interpretation of that data, then start being predictive, move all the way up the chain to artificial intelligence and AI. I don't think IBM's wrong, by the way. IBM's right about this. And they're smarter than I am, so they're just thinking maybe a decade or two out. We're dealing with the now. I think they're dealing with the later. Most companies aren't ready to do AI at that level. And to be honest, AI, machine learning is 18 or 17 known computer science algorithms. It's about the data scientists and the experts to feed the model, more than it is about the technology to run the model. So to kind of wrap up, we put a nice convergent picture here. It's about having multiple systems, IT and OT, complex systems, systems of things, along with systems of record, communicating in an efficient way and a flexible way that can grow as business grows and changes. So this is, I still think we're in the first half of the first inning of this game, and it's going to take a while to go down this path, but it's not impossible. And companies are starting now with the right plan and the right model. Questions? Do we have time for questions?
Yes.
What devices make the most sense, and then, like, you know, once you deploy it, like someone was saying earlier, then you need to maintain it, and many of these organizations aren't IT-centric organizations, or that's not their core strengths.
Yep. So thank you for that question. I couldn't have asked a better one. So we don't. So we made a decision a while ago to say, we are software people, we're going to stay out of the implementation. We will help, obviously, with the pilot. We will help with the system integrator, but we've got a network of system integrators and hardware providers that we have certified on, and cloud vendors. And we say, look, we will suggest a system integrator for you, or if you're already working with one, we've open sourced all of our training and all of our adapters and all of our connectors, not to even charge for anything but the core system. So this world of charging for connectors, I think, is over. I'm going to call Kepware out now. Kepware, you should not be charging for these things. Open source is a real movement, and it needs to be embraced. Our model is certain components need to be fused tightly together for it to be secure and scalable, and that's the piece that we provide. So it's really We rely on our network of partners and specialists in the vertical space.
Are you working with the anything AR, like DAQRI?
No, well, we've danced with DAQRI a little bit, and we want to. So all of these input mechanisms and visualization mechanisms, I think, are extremely relevant for augmented reality and assistance with knowledge of machine.
So can you tell me a little bit more, obviously you know about it, you know that they use GPUs in the helmet.
Yeah.
They run really hot.
Yeah.
Have you seen anybody else doing things like that,
Well,
solutions?
Yeah, nothing in detail. We obviously the Google Glass folks, and then further on, we danced with a company here a little bit, Emerson, and played around with some DAQRI stuff. For us, it's all about API, and as long as we have an API that we can stream data to and do visualizations to, then we'll work with the hardware vendors. So I said I'm not a manufacturing specialist. I'm also not very good at hardware, so I rely on hardware partners to tell me what works.